and gentlemen, for our next attraction.
I want to show you a third and probably our most powerful and flexible method for solving a linear system. It's the addition method. You know, sometimes when you try the substitution method, it's going to get messy trying to solve for one of the variables. You're going to get horrendously ugly fractions. Now you can deal with the ugly fractions, and the substitution method will work if you are, very good with fractions. But if you don't want to deal with the fractions, you don't like the messiness, you can always try
Pay attention, boys. I'll show you how it's done.
the addition method. Now here's the deal with the addition method. We're going to perhaps, sometimes not, multiply one or both of the equations by some number in order that a pair of the coefficients will become opposites, the numbers in front of the letters. We want them to be opposites, positive 2 and negative 2 kind of a thing. So that when I add the equations, that's the next step, adding the equations, one of them will cancel out. One of the variables will cancel out, leaving me with now a single variable equation. Now we're back to what we had with substitution. We'll solve that single variable equation, take the value that it's equal to, and, as in the second half of substitution, substitute it in and find the other variable. And then, of course, as always, we'll check the solution in both equations.
Allow me to demonstrate.
Let's try one. Step 1 is to multiply either equation or both equations by whatever it takes to have opposites. Now, I'm starting you off with an easy one. We don't need to multiply anything. We already have opposites. If you look at the y's, you have a plus 2y and a minus 2y. So we're going to move right to step B and add the two equations. The reason I'll add them with the opposites is that now the y's will cancel out, won't they? Positive 2 and negative 2 make 0. And I'll have 8x equals 11 plus 29, 40. Well, now I have an equation that I can solve for x. It may be x, it may be y. In this case, it's x. And how do I get x alone? But in this case, divide by 8. And I'll know, I'll be halfway there, x is 5. Now remember, I'm looking for a point of intersection. And a point has an x and a y.
The important thing is it your final answer?
So that's not my final answer. I need the y in addition to that. But I have added information. I know x is 5. So my next step is to take that 5 and plug it into either of the two equations. I'll put it into this one because it looks easier. And now all I have is the y, which I can solve for. Let's see. I'll subtract 25 from both sides and divide by negative 2. And I'll have y is negative 2. So, wait a minute. There's one last step.
Why, my little party, just
We think the pair 5, negative 2 works. In fact, we know it works in the second equation. We have to
Allow me to introduce myself. My name is Mike.
try it in the first one. Make sure. You could have made a mistake. And let's put it in.
And you're going to do it because I said so.
Don't do it because I said so. Do it because you may be wrong. You may have made a mistake. And if you do it and it works, you know that you have the right answer. So let's put a 5 in for x and a negative 2 in for y. And 15 plus negative 4, does it equal? Yes, it does equal 11. So I know it works in both equations, and that's the only pair that works in both equations, and I've solved it.
Genius. That's what it is. Sheer genius.
It's not that bad, is it? Now, I was spoiling you a little bit on that one. Let's take a look at another problem.
Houston, we have a problem.
Let's see. The problem with this one is a little bit more difficult,
Whoa!
is that we don't have opposites on the y's, do we? And we don't have opposites on the x's. So as the first step says,
So why don't you fix
if needed, and we need to, multiply one or both of the equations by some integer so that one pair of coefficients becomes opposites. Well, let's see if I can come up with a way to do this to make them opposites. Well, in this problem, I'm going to multiply the first equation by -3. Now, why would I do that? Watch what happens. When I multiply that equation by -3, it's the same equation, and now I'll look at those two now. Well, now I do have opposites, you see, and I'm allowed, as long as I do it to everybody, to multiply by a number. Now I take those two equations, add them, and what happens? Of course, the x's cancel, and I get -15 plus 2 is -13y, and -54 plus -11 is -65, and I'll solve for y by doing what? -13 is multiplying, so in this case we'll divide by -13, and we'll get y is 5. Comes out nice, doesn't it?
Alrighty then.
Well, we're not done yet. We have the y. Take that y and put it back into the other equation instead of y, and now you have an equation that's going to allow you to find x. 5 times 5 is 25. Let's subtract 25 from both sides to get x by itself, and we'll get x is -7.
Cool.
So you now know x is -7 and y is 5, at least for this equation.
Excuse me?
Well, what's the last step?
And you're going to do it because I said
I
so.
think you're going to wish you did this, especially on the test. Plug it back into the second equation to make sure it works for both, because that's what it means to be the solution to a system.
I can do that, but I don't want to.
I think you're going to wish you did. Put a -7 in this case in for x, and the 5 in for y, and let's see, we get -21 plus 10, and son of a gun. Sometimes you're going to have to multiply by some number to get opposites. Now, how to figure out that number? Well, practice, practice, practice. But if you still have trouble, let me give you a method that'll work all the time.
This is a pickle, George. This is a pickle.
This is as hard as it gets. I'm going to need to multiply both equations in this case.
Go!
They're not opposites, and I can't think of some number I could multiply 2 by to get 3. And these aren't opposites, and I can't think of any number I could multiply -2 by to get 5. So, here's what I'm going to do.
This is an intergalactic emergency. I need to commandeer your vessel to
Nope.
Sector 12.
Let me show you what I'm going to do. I'm going to take the first number in the coefficient of x here and multiply the top equation by that. And I'm going to take the coefficient of x in the first equation and multiply that equation by that. Now, I'm certainly going to have two numbers that have the same. That's going to be 6x and 6x. If I flip them like that, it'll always work. They'll be the same. Of course, I don't want them to be the same. So I'll put in one negative. Okay? And let's see what we get. If we look at those two equations, we've got opposites, and that'll always work.
Excellent.
Let's look at the replay.
Let's do that again, slowly. I'm going to take the coefficient of one equation and of x and multiply the other equation by it. And I'm going to flip the coefficient of x of the other equation and multiply the second equation by it. I could have done this with y, by the way. Now I'll have the same numbers and I need opposites, so I'll throw in a negative to either one. And that should give you opposites.
With all due respect, sir, I believe this is going to be our finest hour.
Doesn't get any harder than that. That'll work every time. Now, let's move on to step B and add the two equations. Something's going to cancel out, the x's in this case, and I'll get -15 plus 4 is -11y, and 12 minus 8 is 4. Now, I have to solve for y in this case. So I'll divide by the negative 11 to both sides, and I'll get y is negative 4/11. I like to write my negatives in the top. I figure the bottoms have enough trouble as it is. So the y part of my point is negative 4/11.
Now what am I gonna do?
Well, what I did before. Take that y and put it in for y into the other equation. Instead of y, I wrote negative 4/11. See? And I get 20/11. Now, how do I solve an equation like this for x? Remember the trick to a fractional equation?
LCD, man.
Multiply through by the least common denominator, in this case 11. And I'll get 22x. The 11 cancels for the 20/11, so I get 20. And got to do it to everybody. 11 times 4 is 44. Now I'll solve for x by subtracting 20 and dividing by 22. And I have an answer, 24/22ths, which is really 12/11. You have to reduce it.
Don't make me angry. You wouldn't like
What did
me
you
when I'm angry.
forget? You have to take this solution and plug it into the other equation. It's not going to be that bad, I think you're going to find. We're going to put 12/11 in for x and negative 4/11 in for y. And watch what happens. If it really works, it'll come out sweet. 3 times 12/11 is 36/11. And negative 2 times negative 4/11 is 8/11. And they add up to 44/11, which is 4. It worked. So you got quite an advanced solution here. The intersection of these two equations is the point 12/11, negative 4/11. And it doesn't get any harder than that. Okay. Go practice. Get busy. Dig in on that homework.